This is lit code question number 938, range sum of BST. This is easy question. Let's get into it. Wow, sum of is much bigger than sum down. I think this is good question. Alright, given a root node of binary search tree, return the sum of value of a lot with value between L and R. The binary search tree is guaranteed to have unique values. Let's check with example 1. Root is, okay, I will write 10, left 5, 15, 3, 7, null, 18. I'm gonna traverse with recursion, BFS, and first I just start with 10. In this case, boundary is this one. The reason is, if here is the boundaries between here, so I will traverse not only left child but also right child. But in this case, when I locate here, this is out of boundary because 5 is the lower than 7. In this case, no need to move in here because left side is still smaller because no need to check. Only we need to check the right side. So, and then in this case 15. This one also no need to check the right because right is always above than node value. So at this time I just check this one. It is include equal? No, I will not include equal because it has unique value. It is make sense? Okay, let's implement it. Okay, first I will make variable sum and then def helper, and it will receive a node. And recursion has two cases. One is base case and the second is recurse condition. Base case is if node is none, I will just return. And then recursion relationship is first if node value is bigger than big equal is the node L, and then smaller than right. In this case, I will add some node value, and then I will use global value non-local sum. And then if L is node value is bigger than L, I will recurse helper node left. If R is node value is smaller than R, I will helper. I will check the node right also. And then helper, I will put root as argument and then return sum. Let's check. Okay, looks good. In this case, worst case, it will traverse all node of tree. So time complexity is linear and space complexity, and this recursion use system stack, and system stack size is same as depth of tree. And then worst case, if the tree is screwed left side or right side, at this time depth is same as number of nodes, so we can say it take linear space. Thank you.